All right, 3.7 implicit differentiation, part B. So we're going to start off with what we left off on the part A. Tangent and normal to the curve. So find the lines that are tangent and normal to the curve. X sine 2y equals y cosine 2x at pi over 4 and pi over 2. Okay, so this is implicit differentiation. So every time I derive something with a y in it, I have to tack on the dy dx. And I also have to look out for product rules and quotient rules. Things are being multiplied, things are being divided. So right away I can tell you that this is x times sine 2y and y times cosine 2x. So they're product rules. So u times v prime. So that's the derivative of sine 2y. So that's cosine 2y. But this is a chain rule. Okay? The 2y is the inner function. The sine 2y was the outer function. So I derived the sine to get cosine. The 2y stays there. And then I multiply by the derivative of 2y, which is 2. But see, I just took the derivative of a y. So I have to tack on that dy dx. So this right now is just u times v prime, all of that, plus v, which is sine 2y. Now I'm not deriving that, therefore I'm not just going to tack on a dy dx. So u times v prime plus v times u prime. The derivative of x is 1. I don't really need to write that down. Equals. All right, so u times v prime, so the derivative of cosine 2x is going to be a negative, so I'm going to write the negative right here in the front, negative sine 2x. But just like before, that 2x, that's an inner function. So I'm going to have to multiply this by the derivative of that, which is 2. There is no dy dx because I did not derive y. I'm deriving x. So this is u times v prime plus v, which is cosine 2x, times u prime. So the derivative of y is 1. But because I'm deriving y, I have to tack on the dy dx. So just like before, my job here is now to isolate all the dy dx's. Put them all on one side. So here's a dy dx, and here's a dy dx. So I got to get them all on one side of the equation. And then anything without a dy dx needs to go on the other side. So I'm going to go ahead and I'm going to subtract this from here. And I'm going to move it to the other side. Okay? So simultaneously, because I think you guys can handle it, I'm going to go ahead and subtract this sine 2y from the left side over to the right side. Okay, so let me write down everything, and let me clean up the numbers. For example, that x and the 2, I can write those in the front, 2x cosine 2y, right? And then they are being multiplied by dy dx. Now I moved over negative cosine 2x dy dx. So that's all that's supposed to be on the left side now. On the right side, the negative y, well, you know what? That 2 in the back, let me move that to the front. Negative 2y sine 2x. That's still there. But then I also subtracted the sine 2y from the left. So it should now be on the right. Negative sine 2y. Okay, now the idea was that this canceled out that, and this canceled out that. Okay, next step. Factor out the dy dx's. So what I have now is, okay, dy dx, let's say I pulled those out, and left over is 2x cosine 2y minus cosine 2x. And that equals, the other stuff stayed the same. Right, to get dy dx by itself, I have to divide away everything in the parentheses. So that's my next step. So divide this side by 2x cosine 2y minus cosine 2x, and divide the whole other side by 2x cosine 2y minus cosine 2x. All right, now this is my derivative. Okay, excuse me if I'm not in a hurry to rewrite all that stuff. But I was supposed to find the slope at a certain point. Let me look up there. It was pi over 4 and pi over 2. So this would be a good opportunity to go ahead and plug in pi over 4 and pi over 2. Okay, so that's what I'm going to do now. So dy dx equals, and I'm going to plug in pi over 2 and pi over 4. All right, so let's see. The x is pi over 4 and the y is pi over 2. So negative 2 times y. Y is pi over 2. Okay, times sine of 2 times pi over 4. All of this is going to have to be simplified later. Minus sine of 2 y, which is pi over 2. If you can do it now, great. I'm not going to go ahead and do it and then have you guys like, oh my god, where'd she get those numbers from? So divide. Okay, so 2 times x. X is pi over 4. Times cosine of 2y, which is, let me erase that. Cosine of 2y, so 2 times y, which is pi over 2, minus cosine of 2x, and x is pi over 4. Okay, so simplify this because there's 2's and 4's everywhere, and they can be simplified. So dy dx equals, all right, so negative 2 times pi over 2. So the 2's cancel out, and I'm left with just negative pi. Okay, sine of 2 times pi over 4. This cancels out, and it just becomes a 1, and this becomes a 2. So what I really have is times sine of pi over 2 minus, again, these 2's cancel out, so what I really have is sine of pi. Okay, over 2 and the 4, they become 1/2, right? So what I really have is pi over 2, and then cosine, and then the 2's cancel out, so that's cosine of pi, minus, and then over here this becomes a 1/2, right? So cosine of pi over 2. Okay, and really quickly I'm going to sketch a little unit circle here to help me. Alright, so there's my little unit circle. At pi, the coordinates are -1, 0, and at pi over 2 the coordinates are 0, 1. So I'm going to go ahead and put in my coordinates here. Negative pi stays negative pi times the sine of pi over 2. So I go over to pi over 2 and I see that the sine is 1. Okay, so that's 1. Minus the sine at pi. At pi, sine is 0, so that's a big fat 0. Divide by, okay, pi over 2 times cosine of pi. So I look over here and cosine of pi is -1, so this is just times -1. Minus cosine of pi over 2. So at pi over 2, cosine is 0, so this is one big fat 0. So what I have now is negative pi over negative pi over 2. A fraction inside of a fraction, we don't do this, right? So when you divide fractions, you're actually multiplying the top number by the reciprocal of the bottom number. So negative pi over 2. Well, you know what? Before I do that, there's a negative on top, there's a negative on bottom. They're going to cancel each other out and become positive. So this is positive, right? So I don't have to worry about the negatives. Okay, so anyway, dividing fractions is multiplying the top by the reciprocal of the bottom. So pi over 2 becomes 2 over pi. And then the pi's, they do something magical called canceling out, and my answer is 2. A lot of work, but there is a slope. All right, to save time on the equations, I'm just going to leave them in point slope form. But you are supposed to write equations. So the equation of the tangent is going to be y minus my y1, which is pi over 2, equals my slope that I found, yay, 2 times x minus pi over 4. So to save time, I'm leaving it like this. The normal which is just another word for perpendicular. Also orthogonal. So y minus pi over 2 equals, and this is where it changes, the slope. So the original slope is 2. I need the opposite reciprocal. So that's negative 1/2. Negative 1/2 x minus, and y was pi over 2. Okay, so there are my equations. To save time, I'm leaving them as is. If you really want to, the slope-intercept form is y equals 2x. Yes, that all of that simplifies to that. And the slope-intercept form for the normal is negative 1. Oh, totally forgot about y. My bad. Y equals negative 1/2 x plus 5 pi over 8. All right, so here's the new stuff. Derivatives of higher order. Sometimes you're asked to find the second derivative, and that's what's happening here. Use implicit differentiation to find dy dx and d2y over dx2 for y squared plus 2y equals 2x plus 1. Okay, this is a fairly easy equation. Okay, so it's not like I'm trying to kill you right off the bat. We're going to find the derivative, the first derivative, by deriving implicitly. Okay, so 2 times y dy dx, because I just derived y, plus 2, because that's the derivative of 2y, but then dy dx equals 2, because that's the derivative of 2x, plus 0. All right, so isolate the dy dx's. Oh yeah, look, they're already on the left side of the equation. Great. Factor them out. So dy dx, and then I have a 2y plus a 2, and it equals 2. Next step would be to divide the 2y plus 2. So dy dx equals 2, and then we divide it over the 2y plus 2. Okie doke. So far, so good. Looking at the equation though, I'm like, okay, they all have 2's in common, so I could like totally simplify that. So dy dx equals 1 over y plus 1. And there's my first derivative. Now onward to my second derivative. Now this is a little different. Implicit differentiation, you just derive the entire equation and you end up with dy dx is inside. Well, when you do the second derivative of an implicit equation, you start off with d2y dx2. This is my second derivative, and it equals, and what I'm going to do is I'm going to derive this equation. Maybe not how it's written. I think I'd rather write it as y plus 1 to the negative 1 power. Okay, so that's what I'm going to do. All right, so y plus 1 to negative 1 power. I'm going to bring the negative to the front. That is a chain rule. So the y plus 1 stays intact. My negative 1, I subtract another exponent, so it's negative 2. And now I must multiply by the derivative of the inside. Now the derivative of y plus 1 is 1. But because I derived y, it's 1 dy dx. Excuse me if I don't write the 1. That is my second derivative. Now, when you have a second derivative of implicit differentiation or implicit equations, that dy dx cannot stay there. So, dy dx is, now pay attention, dy dx is, oh, do it in blue, is this, right? Dy dx is 1 over x plus 1. So what I'm going to do is I'm going to plug in 1 over x plus 1, or x plus 1 to negative 1 power, whichever you prefer. No big deal. Okay, so this equals negative y plus 1 to the negative 2 power times, and I guess for the sake of the negative powers, I'll use the y plus 1 to negative 1 times y plus 1 to negative 1. Now these are common terms, so what I'm going to do with their exponents is add. Right, so negative y plus 1, and then to the negative 2 plus negative 1 is negative 3. And there is my second derivative. And I guess I could write this stuff down, right? So notice how this is different than anything we've done before, because you actually do have to plug in the dy dx, because I already know what it is. Okay, and this is my answer. You can rewrite that if you like as -1 over x plus 1 cubed. Same thing. All right, example 3 is going to work the exact same way. I'm finding the second derivative. This is an implicit equation. So 2 times 3 is 6x squared minus 6y, but because I derived y, dy dx equals 0. Okay, so I want to isolate the terms with dy dx's on one side, and the rest are going to go to the other side. So I have negative 6y dy dx equals negative 6x squared, because I moved that over. All right, I got to get rid of the negative 6y, so I'm going to divide it from both sides, and I get dy dx equals negative 6x squared divided by negative 6y. And then obviously the 6's cancel out, so dy dx equals positive x squared divided by y. So there's my first derivative. That was the easy part. Now the second derivative. So I'm going to start with d2y dx2 equals. Now I have to derive x squared over y. It's a quotient rule. So I'm going to end up with, and in case you forgot, v times u prime minus u times v prime over v squared, right? Low d high minus high d low over low times low. Okay, so that's y times 2x, right? That's v times u prime minus u, which is x squared, times v prime. So that's the derivative of the y, which is 1, but because I derived y, dy dx. All of this above y squared. All right, so once again, there is a dy dx in this equation. Here it be. I need to plug dy dx in there. Can't leave it that way. So let me go ahead and rewrite that a little. This will be 2x times y minus x squared, but that's being multiplied by x squared over y, and then over y squared. Now, as you can see, I have fractions now inside fractions. So I need common denominators all the way around. Okay? So I have 2xy minus x to the 4th over y. This is the numerator right here, just by itself. I need the numerator to have the same, denominator, right? So in order to have the same denominator, I'm going to have to multiply the first term by y over y. I'm going to go ahead and get that out of the way. Let me go ahead and write the bottom before I forget. Okay, so, right, basics of fractions. This is just basic. So I get 2xy squared over y, and then minus x to the 4th over y, so I can just write the y one time. Now this is still just the numerator, and then all of this is above y squared. All right, so again, fraction inside fraction. I probably shouldn't write that there. Looks weird. Fraction inside a fraction, right? I just noticed it looks weird up there too. So when you divide fractions, you're actually multiplying by the reciprocal. So I'm not going to have that there. I'm going to go ahead and multiply the top, the numerator, by the reciprocal of y squared, which is 1 over y squared. And now I get 2xy squared minus x to the 4th over y cubed. I need more space. Okay, so that right there is my second derivative. I can simplify this. I don't know that it looks any better. You could split it up, 2xy squared over y cubed minus x to the fourth over y cubed. And the only purpose of splitting it up would be to get rid of some of the y's, but it still looks ugly as far as I'm concerned. For example, these would cancel out, and 2 of these would cancel out, leaving 1 behind. So then this would look like 2x over y minus x to the fourth over y cubed. They both look the same basically to me. So, all right, example 4, same idea. This one has a little thing, extra little special thing that happens that you're going to see in your homework. So, I'm finding the second derivative. I picked an easy equation, right? So 2x minus 2y dy dx equals 0. Isolate the dy dx's, so I get negative 2y dy dx equals negative 2x. To totally get the dy dx by itself, I got to get rid of the negative 2y by dividing it. So dy dx equals negative 2x over negative 2y. I hope you can see that the negative 2 and negative 2 cancel out. So I have dy dx equals x over y. Now, my second derivative, d2y over dx squared, or 2. Okay, so my second derivative is going to be the derivative of x divided by y, which is a quotient rule again, right? No big deal. So v times u prime, which is 1, minus u times v prime, which is 1 dy dx, divided by y, or v, squared, right? Okay, so there's my dy dx again. So I must plug it in, right? I must plug in what dy dx equals. So y minus x times x divided by y over y squared. Again, with the denominators, right? I want to make sure that my fractions make sense. So I'm going to multiply this by y over y in order to get the same denominator, right, as the other fraction. Okay, so I get y squared minus x squared. All of this is over y. And then, fraction inside of fraction, y squared. I keep putting those in the wrong place. All right. Let me give myself some more space. Okie doke. So, I know likey fraction inside fraction. So I'm going to go ahead and get rid of this by multiplying the top fraction by the reciprocal, which is 1 over y squared. Okay, so now what I have is y squared minus x squared over y cubed. Now that y squared minus x squared, that kind of looks familiar. Let me look at the top. Let me look at the top. Oh, it was x squared minus y squared. And so it's kind of reversed. Okay, no big deal. The power of math will help me make that numerator look like the equation we started with, and there's a reason for that. So I want it to look like this because x squared minus y squared is equal to 36. So if I can find in my answer x squared minus y squared, I can replace it with 36. I can substitute. Okay, so I'm going to pull out a negative, right? And when you pull out a negative, the y squared becomes negative, and the x squared will become positive. So I'm going to pull out a negative, and I'll write the x squared first. No big deal. Minus y squared over y cubed. Now, what I have in the parentheses is exactly the same as the left side of the equation that was given to me, what I started with. This right here. So that is the same as this up here, right? So wherever I see that, x squared minus y squared, I can replace it or substitute in what it equals. And in this case, what it equals It's 36. So I come back down here, and my final answer is actually negative 36 over y cubed. And yes, you have to do it. So sorry for you. All right, example 5, finding slope on a circle. Find the slope of a circle, y squared plus, or sorry, x squared plus y squared equals 25 at the point 3, negative 4. Okay, so I'm going to draw a circle real quick. All right, here's my circle. Circles are not really functions. They do not pass the vertical line test. Okay, because each one of those lines is actually touching the circle more than once. So what we do is we consider circles to be a combination of two functions. And the two functions look like this. So here's the first one. It's the square root of 25 minus x squared. And then the second one is negative, and it's the same exact thing. Now those, right, ignoring my vertical lines, y1 takes care of all of this, and then the y2 takes care of all of this. Okay? Now this function, or these functions, are each differentiable, and they work together to create a circle. Well, each is differentiable except for right here and right here, because the tangent line would be a vertical line, and vertical lines don't have a slope. It's undefined. So therefore not differentiable. But anyway, so it would kind of suck to have to derive both of those equations. It is so much easier to just take the original equation of the circle and derive it implicitly. And this is a good example as to why implicit differentiation is more convenient and sometimes mathematically easier or computationally easier than just regular equations. Okay? Well, anyway, so we're just going to derive this implicitly. So I get 2x plus 2y dy dx equals 0. And I'm finding the slope at a certain point, right? So at some point, I'm going to go ahead and plug in my x, and I'm going to plug in my y. All right, so isolate the dy dx. So I move over the 2x by subtracting it. And now I have to get rid of the 2y, and I'll do that by dividing it. So negative 2x divided by negative 2y. Guys, I'm doing a lot of steps that I know most of you don't have to do, right? Like you would have probably automatically just gotten rid of the negative 2's. But I'm just trying not to skip over stuff. So, like I said, these two cancel out. And dy dx is just equal to x over y. And then, oh, wait. I'm adding symbols where I don't need them. I don't know why I made that a negative. 2. I'm on crack. All right, let me fix that. So it's just 2y. I don't know why I made it negative. The 2 still cancel out, but I'm left with a negative x. All right, so there's my slope, right? Because in this class, the slope is the derivative. And I'm going to plug in my points, and that's it. So negative x, which is 3, and y, which is negative 4. The negatives cancel out, so my slope is 3/4. And that's it. Okay? All right, do your homework, and I did not give you a quiz last class, but you will have one next class, and it is going to be on chain rule. So be prepared for that, because I know we're not good at it, great at it, but it's not impossible.